Er.M.N.Ramdas. I welcome you to my channel Maths from Basics for You. So in the previous class I have taught you the derivative of a constant, that is d by dx of a constant equals to 0. So that was class number 5 and today is class number 06. So today I will be teaching you on derivative of a polynomial or algebraic functions. So that is d by dx of x to the power of n, and I have taught you d by dx of x to the power of n. D by dx of x to the power of n is, the solution is n into x to the power of n minus 1. Now after saying that, now it is important for me to derive how we got, if you differentiate d by dx of x to the power of n, how did you get n into x to the power of n minus 1. This is important for you to know. This is about 4 to 5 minutes, you can easily prove it, and afterwards I am going to take some important problems on type d by dx of x to the power of n, which is very crucial for you, and after this you will be able to know what is differentiation, and that will help me a lot in my later classes. So without wasting much of my time or our time, let's start differentiation. That is, before that I remind you of my funda, learn maths from basics. I am here to teach you maths right from basics. So let's start differentiation. To prove the derivative of a polynomial or an algebraic function right now. So d by dx of x to the power of n equals to n into x to the power of n minus 1. Let's see how did we get this. This is important for us. Let's start from proof, and later on I'll do some problems on differentiation, that is of type d by dx of x to the power of n, which is very important for you. Let's start. So let y equals x to the power of n. I call this as equation 1. So what I'll do here, I'll give an increment of delta x to x and delta y to y. Let us see what happens to equation 1. Let delta x be an increment of x and delta y be the corresponding let delta x be an increment to x and delta y be an increment to y. So what happens to equation 1? So equation 1 becomes what? That is y plus delta y equals to x plus delta x to the power of n. So after giving an increment of delta y to y and delta x to x, it becomes x plus delta x to the power of n. I call this as equation 2. So what I will do is, I will subtract equation 1 from equation 2, that is equation 2 minus 1. So equation 2 minus equation 1 gives what? So I call this as left hand side and this is right hand side. So left hand side of equation 2 is y plus delta y, and left hand side of equation 1 is y minus y equals to, on the right hand side of equation 2 is x plus delta x to the power of n, and on the right hand side of equation 1 is x to the power of n. x to the power of n. So what happens here? So this is plus y minus y cancels. You are left with what? Delta y equals to x plus delta x to the power of n minus x to the power of n. You are left with this. I call this as equation 3. So what happens? So y cancels, you are left with on the left hand side delta y equals to x plus delta x to the power of n minus x to the power of x minus 1. So after this what I will do? I will divide throughout by delta x. So dividing this equation throughout by delta x. So I will rub this. So I rewrite this equation from equation 3. We have that is delta y equals to x plus delta x to the power of n minus this is x to the power of n. So as I said, we are going to divide by dividing equation 3 throughout by delta x, we get what? So we get delta y by delta x equals to x plus delta x to the power of n minus x to the power of n divided by delta x. So what has happened? We have divided this equation throughout by delta x. Now what I will do is I apply limit where delta x is tending to 0 by applying limits. Delta x tending to 0 on both sides. We get limit delta x tending to 0 of delta y by delta x on the left hand side. So we will see on the right hand side. So limit delta x tending to 0. So this is x plus delta x to the power of n minus x to the power of n by delta x. Done. Please copy this. So this is equals to limit x plus delta x tending to x of limit x plus delta x tending to x, where x plus delta x to the power of n minus x to the power of n by x plus delta x minus x. Which is equals to n into x to the power of n minus 1. X to the power of n. By using the relation limit x tending to a, x to the power of n minus a to the power of n by x minus a equals to n into a to the power of n minus 1. So, using this relation, I have proved x plus delta x to the power of n, x minus x to the power of n, x plus delta x minus x. It is quite similar to this. So, using this relation, I have proved d by dx of, therefore, d by dx of x to the power of n equals to, this. So, this is an important formula which you are going to remember. Let's work out some problems on this so that you feel very comfortable with this sort of problems. So, this is important. Please make a note of this, and let's start some problems on d by dx of x to the power of n. Problems of type d by dx of x to the power of n, which is equals to n into x to the power of n minus 1. So, we are going to work some problems based on this. So, first problem we'll take problem number 1, y equals to x. I have told you, if you differentiate x, we get 1. dy by dx of x is 1. That is, dy by dx equals to dy dx of x equals to 1. Let us see how. So, what I will do is, I will consider this as equation 1. So, what I will do, see here I want to give a hint which is very important for you. Whatever is a problem, try to bring that problem into a standard form. So, d by dx of x to the power of n. Now, this is not of standard form, but still we can bring it to standard form, and this is how we can do it. So, if you can understand how to bring it, the given problem, to a standard form, differentiating it is very easy. So, I will show you how to go about it. So, what we will do is y equals x to the power x. So, what I will do is I will add 1 to its power. So, y equals x to the power of 1, that is nothing but x. So, for convenience sake, I am adding to the power. We know that x to the power of 0 is 1, x to the power of 1 is also is equals to x itself. So, need not worry, I am going to add. Now, don't you think, if you think smartly, don't you think this belongs to x to the power of n, where n equals to 1? More or less it is of that type. So, let us proceed. Here n equals 1. So, differentiating equation 1, that is differentiating equation 1, we get what? Dy by dx equals to d by dx of x to the power of 1. So, what I will do is, now it is of x to the power of 1, where n equals 1. So, what I will do is, we know the solution. We know that d by dx of x to the power of n equals to n into x to the power of n minus 1, right? So here n is 1. So what I'll do is, which is equals to 1 into x to the power of 1 minus 1, where n is 1. So 1 minus 1, n is 1, 1 minus 1. So what happens here? This becomes what? So 1 into x is nothing but x plus 1 minus 1 becomes 0. This is nothing but 1 because x to the power of 0 is 1. Therefore, d by dx of x equals 1. Hence, I have proved d by dx of x is 1. So let's go for second problem number 2. So this is problem 1. Please copy, or you can pause it. So here I'll write this, instead of writing here I'll write it, this is equals to 1, okay, because on the equation you cannot have two equal signs, so it is equals to 1. So let me rub this. Now problem number 2, y equals minus x to the power of minus 1. See, this looks a little bit difficult, but it is not difficult. Only thing is you have a minus n, but here you don't have minus n. So we can easily solve this problem and bring it to a standard form. What I will do here is, so can I write like this? This is minus 1 x to the power of minus 1. Can I write like this? So forget about this sign, sign is outside. So this is x to the power of minus 1. So this is of this type where n is minus 1. So let's apply differentiation for this. So dy by dx of this, I call this as equation 1. So dy by dx is equal to, I take this minus sign here, minus I'll take so that you will not get confused. I'll add a square bracket. So d by dx of x to the power of minus 1. See, now this is a standard form. So I have brought it to standard form. So what I will do this is equals to, now I will actually differentiate this. So minus 1 I will take as it is. So x to the power of minus 1, here n equals minus 1. So that is n into x to the power of n minus 1. So n is minus 1 into x to the power of minus 1, right? So I bring this minus n outside and multiply. This becomes minus into minus becomes plus 1 into x to the power of minus 1 is minus 2. Done. So this is nothing but 1 into x to the power of minus 2. So what I will do is, you can leave it as it is, or you can further simplify this. What I will do is, if I push this to the denominator, it becomes plus 1. So this also equals to plus 1 by x to the power of 2. That is, I have brought this to the denominator, so this minus and becomes plus sign. So therefore d by dx of minus x to the power of minus 1 equals to this. So a problem which looked difficult for you, I made it easy. All problems are easy, only thing you have to bring it to the standard form and differentiate it. Let's go for next problem. Problem number 3. Y equals 1 by x. Done? So y equals 1 by x. So if I, now this again, this is not of standard form, I will bring it to standard form. This is nothing but y equals x to the power of minus 1. Now here we have plus 1 So if I bring it a numerator, it becomes minus 1. Now it's easy to differentiate. So therefore dy by dx of x to the power of minus 1. So that is equals to, this of type standard form. So minus 1 into x to the power of minus 1 because x is that, because n equals to minus 1. So this becomes what? Minus 1 into x to the power of minus 2. So that becomes minus 1 by x square. If I push this x to the power of minus 2 to the denominator, it becomes plus. Therefore d by dx of 1 by x equals to minus 1 by x square. So remember, this is also an important problem. So please copy this, pause this and copy. So let's go to the problem number 4. Y equals to square root of x. We know that I have taught you d by dx of root x is nothing but half root x, right? I have taught you this in the formula. So let us solve this. See now, root x, that is nothing but, root x is nothing but square root. Square root is nothing but x to the power of half, because this is nothing but square root. So for example, if you have cube root of x equals to x to the power of 1 by 3. If you have fourth root of x equals to x to the power of 1 by 4. Similarly, nth root of x equals to x to the power of 1 by n. So using that logic here, can I write this as x to the power of half? So y equals x to the power of half. Now this is the standard form which can be differentiated easily. So therefore dy by dx equals to d by dx of x to the power of half. So here n equals to half. So using the standard relation, that becomes, now we are differentiating this, n into x to the power of n minus 1. Here n is half, half into x to the power of half minus 1. Okay, half. This is, I take this half outside the bracket. Okay, I take it outside and I will differentiate. Now some minus 1, I take this. 2 is LCM. 2 goes one time, 1 into 1. 1 minus 1 goes 2 times, 2 into 1 is 2. This is plus 1 minus 2. That becomes minus 1 by 2. This is x to the power of minus 1 by 2. So if I bring it to the denominator, it becomes what? This becomes half x to the power of half. So what I said, x to the power of half is what? Root x. So this is equals to half root x. Therefore, I rub this. Therefore, d by dx of root x equals to half root x. So I have proved that. Fourth problem is over. I rub this. Now, problem number 5. Y equals minus 1 by x square. So, what I have done? I have taken minus 1 by x square. Let us see what happens. So, here I have now, this is not in standard form. I have to bring this into a standard form. How to do it? I will show you. This can be written as what? Minus 1 into x to the power of minus 2. Can I write like this? So this x goes to denominator, numerator, and this plus will become minus sign. This plus will become minus. So what I will do is, I will take this as minus. So let's differentiate this. Now we can differentiate it because this can be easily differentiated because this is of x to the power of n type. So what I will do? Therefore, dy by dx equals to d by dx of minus 1 into x to the power of minus 2. Alright? Minus 2. What I will do here? I will take this minus value here and say d by dx of x to the power of minus 2. See now, I have brought this one outside. So d by dx of x to the power of minus 2 is nothing but here. Here n is minus 2. Here n equals to minus 2. So now differentiate this. What I will do? I will keep this minus 1 outside. Now, so n is minus 2 into x to the power of minus 2 minus 1. Right? That is now minus into minus plus 2 ones are 2. This becomes 2 into x to the power of minus 2 minus 1 minus 3. So this becomes minus 3. So this is nothing but 2x to the power of minus 3. So what I will do is, I will push this x to denominator. So that becomes, so therefore d by dx of 1 by x square equals to what? 2 by x cube. 2 by x cube. Done? So similarly, when you get problems like this, try to bring it to the standard form and solve it. Now, let us go to problem number 6.